In this video, we're going to look at one of the functional groups called alcohol. Alcohol is, as you can see over here on the right, it is a carbon chain. So this R represents whatever carbon chain, and then you have OH connected. All right, so here are the rules for naming alcohols. For instance, we have that carbon chain 1, 2, 3, 4, 5, and then we have an OH attached. So this would be a pentane normally. I'm going to write it down here because I don't have enough room at the top. But when the first rule says you're going to change the ending, you're going to take the E off and make it an OL. So it would become pentanol. And you can have more than one OH group, more than one hydroxide group. But if you only have one, you're going to assume that it's at carbon number 1. So this would be carbon number 1 right there. So this would be carbon number 1 right here. And then we would have our other 4. So this is 1, 2, 3, 4, 5. If you have multiple hydroxide groups attached, you're going to use di and tri. So it would be pentadiol or pentatriol. And you would have to use the number ending. If you have a multiple bond, like a double or a triple, remember an E for double and Y for triple. So we could see a pent ENOL. That would indicate that there's a double bond, and usually they're going to have a number here telling you where the double bond is, and perhaps you have a number here other than 1. Maybe you have the OH off of that second carbon, so you can plug numbers in there. The OH takes numbering priority, so if you have a choice between a double bond and a triple bond, you're going to look at, and the OH, you're going to look at the OH to decide the numbering. So here are some examples. Let's take a look at these. We have, in this first example, we have 1, 2, 3, 4 carbons, so that's a bute. They're all single bonds, so it's butane, and we change the ending to butanol. Now, we would know that this is a 1-butanol, but we don't have to write the 1 because if there's no number, it's assumed to be just the 1, so it's butanol. Let's look at another example. Over here on the right, we have 1 carbon, 2, 3, 4. So this again is a bute structure. It's all single bonds, so it'd be on the butane. And we have an OH on there, so we have butanol. It is not on the first carbon position, and I'm going to number in this direction, so I would have a 2-butanol. Looking at this lower one down here, again, 1, 2, 3, 4, 5 is my longest structure, so this would be a pentane base. So it's pentanol, but there's 2 OHs, so I'm going to go with pentadiol, and I need to number it then. So I'm going to number in this direction. This is 1, 2, so there's a 2, 3 pentadiol. In our last structure, I see 1, 2, 3, 4, 5, 6 carbons, so that's hex. I have a double bond in there, so it's hexene, and I have an OH, so hexenol, and I need to say the OH is here on the first carbon, so this is going to be 1, 2, 3, so it's a 3-hexenol. Now the 3 is referencing this double bond. Okay, so you can see it's not anything different with the naming structure that we've been doing. You count the longest continuous chain, you locate the branches. In this case, the branches are OH groups, they're OH alcohols, the hydroxys, and you're going to assume that they're going to be in carbon 1. They take the priority if you have multiple options.